Hello class, we'll continue with our next numerical method, which is again a bracketing method. The name of this method is false position. It's also called as Regula Falsi. So any of these names comes in the exam, don't get confused. Okay, both of them are one and the same. This is again a bracketing method, which means that it gives us the root of this equation within a given bracket. Alright, let me just give you a brief theory of this. Suppose we have a function fx which has a curve which goes something like this. Okay, what we have to do is find out a root of this equation within the bracket x0 and x1. Okay, here with the help of our formula, what we're going to do is we're going to find out the values. That will be something like this. The first value, the x2, which will be somewhere around here. Again, we'll go and check the values of x2, fx2, fx1 and fx0. Alright, so suppose, as we can see here, supposing that this is the actual curve. Okay, so as we can see, x0 has a positive value, x1 has a negative value, which means that there has to be a root between them. Alright, as we can see, for x2, we drop a perpendicular here, we can see that this still has a negative value, so this is a bracket. Okay, x2 to x1 is a bracket that we can ignore. Alright, because as we can see very well from the curve and from the values, that there is no root lying in between them. Right, this is the point that we are interested in. So x0 to x2, that will be our bracket, and to this bracket we'll apply our formula again. Okay, alright, so next iteration is going to be something like this here, and so on and so forth. Okay, alright, x2, then x3, x4, as many iterations as it takes. Just like similar to the bisection method, most of the times the number of iterations and the bracket will be given to you. If it doesn't, you can follow the same method that we followed in class for bisection method. Just go for arbitrary trial and errors, put x is equal to 1, then x is equal to 2, get the values, get a sign change. Like for example, f2 has a positive, f3 has a negative, something like that. Then there is a root in between them. That's what we have to do if the interval is not given. Alright, so I'll just give you the formula for this. Alright, x2 is equal to x0 minus x1 minus x0 divided by fx1 minus fx0 into into f of x0. Alright, okay, let's take a look at this. x2 is equal to x0 minus x1 minus x0 divided by fx1 minus fx0 into fx0. Alright, I hope this is visible to everyone. Let's take a look at this one. Alright, please notice one thing, that for the first iteration, when we have got the bracket, we have got the number of iterations. For the first value, what we do is use x0 and x1, these values just as they are. Okay, for example, suppose we get a value of x2, and suppose that f of x0 was positive. Okay, f of x1 was less than 0. Okay, we get the value of fx2, and f of x2 was also positive. Okay, then our next interval is going to become x2 to x1, right? Okay, because sign change occurred, and x0 was also positive, x2 was also positive, so x0 to x2 is an interval that we can neglect. So the interval that we are going to concentrate on is x2 and x1. Okay, so this bracket, and we are going to apply the same formula here also. All right, and here just make sure that you write down all the values of fx1, fx1, fx0, fx2. Make a kind of a rough table on the side, or on your rough sheet, which will have, say, values of x and fx, something like this. Okay, make a bracket, and I think that will help you, because you have to go on doing multiple iterations, and knowing all the values at just one glance is always better. So make a note of that. Alright, so it's better to write, like, after you have gotten the next interval x2 to x1, here, before applying this formula again, suppose, consider x0 will be equal to whatever the value in between these. Okay, so here the x2 is the smaller value, so I'll write x2 minus, okay, x2 means the whatever value of that. Okay, and fx0 will be fx2. Okay, just for the sake of this formula, and then x1 will be whatever the value, and f of x1 will be whatever the value. Okay, alright, so make sure that you get this in the written before you start the next iteration. Then again we'll apply the same formula. Now we are going for the second iteration, so it's an x3, and using these values again you have to do the same thing. Just the values are here. Okay, so first thing, let us go to the beginning once again. For the first time, what we do is we select a bracket or an interval. Okay, x0 to x1, that was our interval. Okay, for that interval we found out what the values were for fx0 and fx1. Then we apply this formula, x2 is equal to x0 minus x1 minus x0 divided by fx1 minus fx0 into fx0. Okay, then what we do is we check out the sign of fx2. Okay, so that we can eliminate one part of that interval or that bracket. Okay, and we consider what our next interval is going to be, what our next bracket is going to be. This is just a kind of you can say dummy thing that I have assumed. Okay, so it's not necessary that fx2 will always be greater than 0 and our next interval will be x2 to x1. It may well be x0 to x2. Alright, so make sure that you do this step carefully, considering your next interval, and that is the key to successful calculation of this. Okay, so again x2 to x1, this is the interval that we found out for the next iteration. Then okay, make sure that you get these values written down. Consider that x0 is equal to x2. This is for this case, it may be different for another. Okay, what is fx0, which is equal to fx2. Okay, what is x1, what is fx1. Okay, write all these values carefully and then proceed with the next one. Then again for the next iteration we'll have to determine our interval depending on the sign of fx3. Okay, and then again consider your interval, again write down these values, and then again continue. Okay, again a lengthy method, remember, but also gives very accurate routes if you follow it through. And usually these methods are mostly used if the equations are kind of linear, having many different kinds of functions. For example, in the last class we saw the examples such as x e raised to x is equal to cos x, something like that. It has different types of functions, but still it has something like fx minus fx1 minus fx2 is equal to 0, that kind of equation. So in these kind of equations these methods are very useful, and I think that should be enough of theory. We can now proceed with some practice problems. Let's see. Okay. Hope it's clearly visible to all. Okay. What we have to do is we have to find out the fourth root of 32 up to 4 iterations using Regula Falsi. Okay. So here, let us first try to convert this expression into an equation, because we need an equation. Okay. So here we assume that x is equal to 32 raised to 1 by 4, that is fourth root of 32, right? Which means that x raised to 4 will be equal to 32. Okay, which means that x raised to 4 minus 32 is equal to 0. Okay, this is our function dfx. Alright, now as you can see here, the interval is not given. So what we'll do is, let us find out what happens to fx when, say, x is equal to 1. Alright, 1 raised to 4 minus 32, that is minus 31. Okay, what happens when this is equal to 2? That is 2 raised to 4 minus 32, that is nothing but minus 16. Fx is equal to 3 raised to 4 minus 32. 3 raised to 4 is 81 minus 32, that is 49. Okay, alright, so alright, here as we can see a sign change has occurred, minus 16, 49, which means that there is a root between x is equal to 2 and x is equal to 3. So our interval is 2, 3. Alright, now for the first iteration, just one sec. Alright, yeah. Okay. Here as you can see, I am clearly mentioning all the facts. Okay, x0 is equal to 2, x1 is equal to 3, fx0 is equal to minus 16, fx1 is equal to 49. Okay, all the values in the formula are clearly mentioned. Now I can put these values in the formula, x0 minus x1 minus x0 divided by fx1 minus fx0 into fx0. Alright, let's see. So 2 minus 3 minus 2 divided by 49 minus 16 multiplied by minus 16. 2 minus 3 minus 2 is 1. 49 minus 16 is 49 plus 16, which is 65. Okay, and multiplied by minus 16, so this should become plus 16 divided by 65. Okay, that is equal to 16 divided by 65. That's 0.2462 plus 2, so that's 2.2462. Alright, we're going to find out what the value of fx is for this thing. So this is x2. What we want to find out is what is fx2. Alright, so 2.2462 raised to 4. I'm sorry, 2.2462 raised to 4 minus 32. Okay, fx2 is minus 6.5438. okay, as you can see here. Okay, all right, which we can see is less than 0, which means that the interval that we want to choose next will be 2.2462 to 3. Okay, which means that again we'll write down the values. x0 is 2.2462, x1 is equal to 3, fx0 will be equal to minus 6.5438, and fx1 is equal to 49 again. Alright, again I have, as you can see, I have clearly mentioned all the values, and then again applying the formula. x3 is equal to x0 minus x1 minus x0 divided by fx1 minus fx0 into fx0. I'm writing down this formula again and again. I would suggest that you do the same, because the regular falsi method or false position method and the secant method, which is the method after this one, they have formulas which are pretty similar to each other, so it's very easy to get confused between these two. So it's better if you write down this formula every time. Okay, just repetition, that is going to give you enough practice. All right, okay, so divided by 49 minus 6.5438 multiplied by minus 6.5438. Let's see what the value of this is. Okay, as we can see, after this calculation what we have gotten is 2.3350. that's our x3. We'll find out what our fx3 is. Let me just go through this. Right, okay, raised to 4 minus 32, okay, so minus 2.2729, which is still less than 0, which means that our next interval is going to be between x3 and 3, which was the initial x1, right? So we're going to do the same thing again. This is the third iteration. X0 is 2.335, x1 is 3, okay. F of x0 is equal to minus 2.2729, fx1 is equal to 49, okay, just as it was. And again, going for the formula, now this is the third iteration, which means that x4, now remember, it's also easy to get confused, like x0 and x1 are the initial values that we assume. So the third iteration becomes x4, okay. First iteration is x2. So usually what happens is, in the hurry of the exams, as soon as we get to x4, we think it's the fourth iteration and we stop. Don't stop, okay. Just do this, make sure you know what iteration you are doing, okay. So this is the third iteration where we are getting x4, okay. Again, x0 minus x1 minus x0 upon fx1 minus fx0 into fx0, okay. So which is 2.335 minus 3 minus 2.335 divided by 49 minus 2.2729 multiplied by minus 2.2729. Okay, let us see. Sorry, let me go through that once again. 3 minus 2.335. Is 2.3645. Right, let's find out what fx4 is. Minus 0.7423, still negative, okay. So please note that this is an kind of unique example where we haven't changed the positive side of the bracket yet. Still we are getting the negative roots, okay, which means that our next interval is going to be 2.3645 to 3. All right, we have to go up to fourth iteration. So this is our last iteration. Again, we write down x0 is equal to 2.3645, x1 is equal to 3, then fx0 is equal to minus 0.7423, and fx1 is equal to 49. I don't change that yet, okay. So again, let's go for the final iteration. let's try this, right, which is 2.3645 minus 3 minus 2.3645 divided by 49 minus 0.7423 multiplied by minus 0.7423. Alright, so 3 minus 2.3645 divided by 49 minus minus is plus multiplied by 0.7423. okay, and again minus and minus becomes plus, so 2.3645 plus the answer. Excuse me. So as we can see, this is it. We have gotten to x5, which is our fourth iteration, and they have asked us for 4 iterations, which means that we have reached here. No need to find out what fx5 is after this. Only find out fx5 if you need to go further, find out the next roots. Alright, so I think that's it for this problem. Let's continue with the next one. Okay, let's go for the next problem. Okay, so that's our problem. Alright, let's go through this a bit quick. Right. Okay, so f when x is equal to 1 is first set your calculators to radian mode, right? Okay, f when x is equal to 2 is equal to now take a look at this. When I took x is equal to 1, the value was minus 2.178. When I took x is equal to 2, the value moved away from 0. Sometimes that can happen. So here I think it would be advisable if we find out what x is equal to 0, value of fx when x is equal to 0 is, which means that cos of 0 minus 0 into e raised to 0, which is going to be 0 anyway. Take a look at this one. Okay, so this positive 1 plus 1. Okay, so this is the interval that we were looking for. 0 to 1 sign change occurred. Alright, so let's go with the first one. x0 is equal to 0, x1 is 1, fx0 was positive 1, fx1 was negative 2.178. okay, so x2, which is our first iteration, that is going to be sorry, I think it's out of focus a bit. Okay, let's find out what fx2 is going to be. Alright, cos of 0.3147 minus 0.3147 multiplied by e raised to 0.3147. okay, 0.5198, which is greater than 0, which means that our next bracket is going to be 0.3147 to 1. okay, alright, second iteration. x0 is 0.3147, x1 is 1, fx0 is 0.5198, fx1 is equal to minus 2.178. Alright, is it clear, visible? Alright, yes. Now we go for x3, which is nothing but 0.3147 minus 1 minus 0.3147 divided by minus 2.178 minus 0.5198 multiplied by 0.5198, which is equal to let me just go through this again. I think there's something wrong with my Okay. I think, yeah, that's correct. 1 minus 0.3147 divided by 2.178 plus 0.5198, so it is multiplied by 0.518 plus 0.314, which is 0.4467. sorry about that. fx3 is fx3 is nothing but cos of 0.4467 minus 0.4467 multiplied by e raised to 0.4467. This is equal to 0.2036, which is a positive. Okay, so which means that again we have to neglect the positive side interval. Next interval is going to be 0.4467 to 1. Okay, alright, so the third interval, okay, x4 is going to be 0.4467 minus 1 minus 0.4467 divided by minus 2.178 minus 0.2036 multiplied by 0.2036. Okay, the value of this is the value of fx4 is sorry 0.708. okay, 0.708, which is again a positive value, which means that the positive side interval will have to neglect once again. Alright, so the next interval is 0.4940 to 1. Alright, so now going for the fourth and final iteration, x0 will be 0.4940, x1 is again 1, fx0. Okay, so fx0 is 0.0708, fx1 remains minus 2.178. alright, so going in for the final iteration, which is nothing but x5, which will be equal to 0.4940 minus 1 minus 0.4940 divided by minus 2.178 minus 0.0708 multiplied by 0.0708. sorry about that. Okay, alright, so this one is 0.0708 5099, which is our answer after the 4 iterations. Okay, so we don't need to find out what fx5 was, as we have reached the end of the solution. So I think that should be it. We'll solve some more problems in the class for practice. So make sure you watch this video and learn this method well, because again, a very simple method, a very basic method, but it can definitely score you some good marks in your exams. Okay, so do well. Good luck.